Let's talk about the electric field due to a point charge. So this is the formula for the electric field. And you can see here we've got the E, capital E for the electric field. And this is the magnitude of the electric field. The Coulomb's constant, again, that's 9 times 10 to the 9th Newton square meters per square Coulomb. Capital Q, because we're talking about the charge magnitude, and R. Now this formula looks very similar to Coulomb's law, but the difference is we only have one Q, and because there's only one Q, R isn't the distance between the two objects because we only have one object. So what is R? Well, if you have your charge, your point charge, say, here it is right here, we'll call it a positive one, and I want to find the electric field at some point due to this point charge. So let's say this is point P. Okay. I'm interested in the electric field here at point P. So what is R? R is the distance from my point charge to point P. Now, if this is a sphere, some kind of macroscopic object, then it's from the center of that object to point P. And we call point P, this what I'm calling point P, that's the point of interest. That's where I'm trying to find the electric field. It doesn't have to be where I drew it. I could be interested in finding it down here. Okay? So I'll call this P1. This could be point P2. Okay? R is still the distance from my charge distribution to the point of interest, in this case, P2. This would be R from here to here. For 1, it's here to here. So you have to know where your point is and use that to help you determine what R is. Now, as far as the direction of the E field goes, the E field always points directly away, or I should say it comes directly out of a positive charge. So in this case, I have a positive charge, so my E field lines would be like this. If it's a negative charge distribution, so let's say I have a negative point charge, then they point directly in, like so. Now, this is how we get the direction of the E field. It points directly away from a positive charge, directly towards a negative. So it basically goes from positive to negative. Now, this is when you're looking at an isolated charge. If you start getting charges close together, the overall net E field is going to look different. What I've drawn here is the electric field due to the respective charges. It's not the net electric field, it's just the electric field due to those charges themselves. If you start looking at a net electric field, you could have something crazy. You could have, for example, let me do this in a different color. I could have some kind of strange shape like that. That could be positively charged, and this could be negatively charged. And my E field could do something like this. This is the net electric field that I'm drawing now. And I can draw many, many more E field lines here. I'll just draw a couple more. I'm not going to draw all of them. Now, we might, now what we're looking at here is the net electric field, but we might be interested in what the direction of the E field is at a specific point. So for example, maybe I'm interested in this point right here. I want to know what's the direction of the electric field at that point. Okay. To get the direction of the electric field there, you just draw the tangent to this curve that I've drawn. So at this point here, that means the electric field would point something like this, roughly. But if I look at, say, this point over here, and I draw the E field, at this point, the electric field is going to be roughly something like that. It's tangent to the curve of the E field line. These are E field lines. This is showing us, giving us an idea of what the direction of these E fields are. But if we want a specific point, we draw basically tangent. At that point, we draw the tangent line, and that tells us the direction of the E field at that point. But the key ideas here is electric fields go from positive to negative. And when they do enter the object, so at the point, you'll notice here I tried to draw them so these lines are all actually perpendicular to the object. And I tried to do the same thing here. Not always perfect, but that's what I was trying to do. It's always kind of perpendicular to where it comes into contact with the object.